So I'm going to talk to you guys today about our monitoring program at Cisco. I'm going to start with just a brief introduction. My name is Matt Valites. I'm an information security investigator for the computer security incident response team at Cisco. I've been doing this now for about 8 years. I'm also the site lead at our West Coast operations in Silicon Valley. I'm a former Unix and Linux administrator. I've done a bit of Oracle database administration back when the versions were single digits. And I spent a couple years torturing myself doing some SendMail administration as well for a hosted email as a service offering. I'm also a co-author on a book that is going to be released in the spring of 2015. It's going to be released by O'Reilly. You can see it up there. It's with two of my colleagues that are also investigators. And this book came about, we give a lot of support, sales support for Cisco. We meet with customers, and salesmen bring us in there to sort of establish a level of trust with the customers to prove that Cisco sort of knows what they're doing. We don't sell anything, but we just tell them what we do, very similar to what I'm doing here. And we saw, when meeting with these customers, some pretty large customers in all different verticals, that there was a general gap in how people structure their security monitoring and what they do. A lot of people seem to think that you can just buy a product, you can buy a SIM, you can drop it in there, you can throw your data at that SIM, and that SIM is going to produce events, and then you profit. That doesn't really work that way. If I purchase the same SIM as you do, and you deploy it, and I deploy it in my environment, how is that customized for my environment? What is there that differentiates how you use that from how I use it? You can certainly pay professional services, PSG, to customize that and develop monitoring techniques that are specific to your organization. What we prefer to do is we prefer to collect all the information that we know is valuable to us in a very prescriptive way, and then we write logic to search through that data so that it's meaningful to us. And that's what I'm going to talk about today. So my team, CSIRT, we're responsible for incident response and security monitoring for Cisco. We don't provide these services for customers, so we are not a revenue-generating part of Cisco, kind of an insurance agency, I guess, if you want to think of it that way. We are responsible for doing that monitoring for all of Cisco's DMZs, their data centers, the labs, diversified business units like Ironport and WebEx, extranets, anything, any asset that Cisco owns, that is what we're responsible for doing, for monitoring, excuse me. I don't think that Cisco needs an introduction. I'd be really surprised if there was anyone in this room who isn't aware of them. Most people probably think that we're a switching company and that we build routing devices, which we do, but we do have quite a bit of other offerings, some hosted as well. And I'll get to at the end here a case study that is a hosted service, and we're going to apply this security monitoring methodology to that hosted service. But just to sort of quantify what Cisco is, to give you an idea of the landscape in which we operate, numbers work, right? Everyone's been showing metrics the last couple days. We have points of presence in over 100 countries worldwide, over 100,000 people, a whole bunch of servers. There's two real numbers on here that stick out to me that sort of really set the stage for what it is that we do. The first is the number of routers that we have. I have a colleague who's actually a co-author on the book who likes to say that if ever there was a small possibility or a minute possibility or any amount of chance that any problem at Cisco could be solved by building a network, you're pretty damn sure that we're going to build another network. And that's how we get somewhere on the order of 40,000 routers. It's a little bit obscene. The other number that really sticks out there is how many IPv4 prefixes that we announce via our AS. And this is Cisco's and all of our diversified business units as well. So again, Ironport and WebEx, though Cisco accounts for by far the vast majority of those. But we have 208 IPv4 prefixes, which is, as you can see, just over 1.25 million public IP addresses that we manage. So I'm sure many of you probably can memorize the prefixes that you're responsible for. There's absolutely no way that we're doing that here. So you take that many publicly routable IP addresses, you add in the 40,000 routers that we have internally, put a bunch of network address translation on those routers, and you're just talking about an absolutely massive network that we have to deal with. And that's just the way it is. So with that amount of environment, it produces quite a challenge for us. I just want to frame up what we're really operating with here from a security monitoring and incident response standpoint. Again, some more numbers here. We collect DNS queries. We collect these off the wire for the most part. We have a system that essentially takes a tap at our egress points, and we collect UDP and TCP 53 traffic. And we're just storing the queries. And I can spend a whole hour discussing how we do our DNS query logging if you really are interested. But it amounts to 2.5 trillion, somewhere on the order of 2.5 trillion requests a day. We have a massive amount of IDS sensors. Again, these are deployed globally. It's over 300, generating 1.5 million alerts. So there's a lot of data that we have to search through. It's not really feasible for us to go to a system administrator or an application developer and say, send us star.star syslog facility, syslog priority. Just give us everything, and then we'll figure out what we want. That doesn't scale, both in terms of resources, human resources, and the solution that we use to store this data, for the most part, is a volume-based licensing. So we have to pay for what we store, which means that we have to be really prescriptive about what we're using. We try to get two different types of data. We want to store things that we can proactively detect on, so that's for our security monitoring. And then we also want data that we can use for investigations. So this isn't necessarily something that we're going to set up some monitoring for, but it's something that we might need if we have to go back to a point in time and figure out what happened. One last thing that I want to mention here, there was some talk yesterday about numbers of incidents. Incidents is, I think it's a matter of semantics, what you call an incident, what you call an alert. To me, an incident is something that you actually are investigating. Maybe you've confirmed that it's malicious. Maybe it's something that you work on. It's different than an alert. An alert to me is something that your IDS, your antivirus, is generating and telling you, hey, something happened. That's an alert. I think the number that Tomas gave during yesterday's talk was that it was 8 million incidents. And I gather from that talk that what he really meant was alerts. Are you going through 8 million alerts a day? I don't know how you could do that, right? So just because your system is generating these events, it doesn't necessarily mean that you're actually going to pay attention to every one of them. So what do you do, right? How do you actually filter through and determine what is meaningful to you? And that's what the basis of this talk is about. We're going to start by discussing our monitoring methodology. And this is a portion of the book. It's the main portion of the book. It was the impetus for writing it. Once we discuss that, we're going to move on to what we call our playbook. And this is our structured format for how we actually manage our detection logic. And then we're going to take those two, and we're going to apply it to this case study of the cloud. OK, so let's start with our monitoring methodology. We've essentially boiled down an approach into 4 simple questions. This is by no means rocket science, and I hope once I show these that you look at it and you say, wow, that's incredibly obvious, Matt. I could have thought of that. What you do with these questions is this is how you approach any problem that you need to. We all likely have very similar environments in some degree. We have an Active Directory environment. I'm sure many of you have an Active Directory environment. We have executives. I'm sure you have executives. So there's some similarities and commonalities that we have, and you can apply these 4 questions to those environments. But really what this is, where this comes in value is when you start talking about what differentiates my organization from your organization, and what do you have that's specific to you that you really need to protect, and how do you actually go about protecting it. And so the first question you need to ask yourself is, what is it that I'm trying to protect? Now, this seems kind of obvious, but you have a lot of stuff on our network. Like I mentioned, we have 40,000 routers. Do we need to protect every single one of those routers? Probably. Are there some that are more important than others? Certainly. Do you belong to a healthcare organization? Do you have customer personal identifiable information? Do you process credit cards information? These are the types of things that, if you start asking the questions, you can start focusing your efforts on those environments. I mentioned it's an iterative process, so really, especially within our organization, this process will never end. We will continually be asking these questions every single time. Some of it is proactive. We have to go out and we have to say, okay, you know, I heard that there's this other project over here that they're starting up. They're working with this customer. Maybe they're doing a new service. I think they're collecting some device support, device configuration supports. That's probably important. There might be customer credentials in that. It's something we should look at. Some of it, some people come to us. We have processes built in where there's baselines for security, and it doesn't cover just monitoring. It covers everything from the types of logs that system needs to generate, the secure development lifecycle. It's really all facets of information security. And so some of our monitoring engagements, we get involved via that method. We're pulled into it, but it's not limited. It's both methods. Once you figure out exactly what it is you're trying to protect, now you have to figure out, well, what exactly are the threats against those assets? So if I have credit card information stored in a database, somebody might be going after that database. If I have a web front end, somebody might be trying SQL injection, cross-site scripting. So you have to figure out what it is that is likely to get attacked and from where it's coming. Once you figure out what the threats are, you got to figure out, well, how do I actually detect them? So now we've got assets that we know are worth protecting. We have some potential threats against those assets, and now we have to figure out, okay, I know I need to detect a SQL injection attack, but how do I actually do that? What information do I have available to me that's going to generate events that I can look at? So in some cases, it might be logs, right? This is syslogs, web application logs. Knowing what you want to detect means that you can go to that system network admin or application developer, and you can say, you take input, I need to see what that input is. Are you generating logs that contain that information? In my experience, the answer is typically no. An application developer is not necessarily going to know what you, as a security practitioner, are interested in from a monitoring standpoint. That's just not what they're thinking about. What they're thinking about is, okay, I've got all these different steps along the way, and I've got a couple bugs, and I need to put in some debugging statements here so that I can understand when things are breaking, where is it breaking. That's what they're doing. So if you have executed function A, executed function B, that's not useful to you. That's useful to a developer. It's not at all useful to you. So one of the things that we've done, and when I say we, I don't necessarily mean my CSIRT team, I mean our greater InfoSec team. We've developed a logging policy that's very prescriptive, and this logging policy states the type of events that we want to have generated. So these are things like if you see administrative actions being performed, if you see authentications, if you see password changes, if you see accepted or closed network connections. These are all the different types of things, and we lay it out very prescriptively. These are the types of events that you need to generate a log message for. Additionally, that logging policy also includes what it is you need to include in that log event when it fires. So for instance, we have gone to developers and they said, okay, well, you know, here, somebody logged in, we created this event, and we get a log statement that says user A logged in, and that's literally it. There's no timestamp, there's no source from where it came from. So you have to include these things. So you have to say you have to include a timestamp, you have to say what time zone you want it in, you have to state where you want these logs sent to. And so we made it a policy within Cisco. And anytime anyone develops or stands up a system, they're responsible for ensuring that their application or their systems are generating these log messages so that we can consume them. And the whole consumption of these messages is another whole topic that is quite difficult. When you're in an organization this large, you can't just have one central syslog or Logstash or Splunk server where every application is sending its data. It doesn't scale. So you have to work with these groups to stand up their own collection environments, and then you have to work to get a feed from those environments, again, for the types of information that you want for proactive detection, as well as the things that you want for reactive investigative logging sources. Often what we do is for the proactive monitoring, we pull that data into our own system. So we account for that in our licensing. Things that we want for investigative support, we'll leave that in our client, essentially, in their systems, and just request access to it for our team. So that way, we don't have to bear the burden of something that we're only going to need potentially if there's an incident. So it helps with licensing. And that's really it. Once you've figured out that base level of monitoring, the last thing that you have to do is actually figure out what is it that you're going to do when an event generates. How do you respond to that? It's a bit of a philosophical debate, I suppose, whether it's worth monitoring if you're not going to do anything for it. I've gotten into some debates about that. But who is going to react to an event? In an environment as large as ours, there's absolutely no way that we can be responsible for understanding necessarily every event that fires. Certainly we do to some degree, but we're not responsible for that system to go back and understand, okay, well, is this normal? Do you expect to see this? Is this something that we can tune out? So you have to have escalation paths already set up with these organizations so that they can provide the context for the event that you're seeing. I should say that the time to set up those escalation paths and those relationships is not when the event is firing or during an incident. That's the worst time to do it, though sometimes that's just what happens, and that is how you identify who it is that you need to work with. But these are proactive engagements, and we have a whole bunch of exercises that we go through with different teams to make sure that these escalation paths are clearly defined, they're documented, and then that they're tested. We're actually going through what we call a tabletop exercise right now for this environment that we're going to take a look at the case study. And what we're doing there is we set these scenarios, and they're fake scenarios. They're real in the sense that they could happen, but they're fake in that we're not actually going to see an event on the wire. We're going to say, hey, this is a likely scenario. We're going to pretend that this happened, and then we're going to walk through this event to ensure that all the processes are there, all the players that need to be involved in this exercise are aware of it, and then that we actually can use the output of that exercise to ensure that any missing processes are there, that our management is aware of the gaps and can actually address it. It's a great way to ensure before incidents happen that you have all this stuff ironed out. And so that's the monitoring methodology. Like I said, it's not rocket science by any means. It's really simple. But if you apply that iteratively over and over to every engagement that you have to have, you're going to build up a set of detection techniques that you can apply or that you can monitor for on a regular basis. So now that you've got all these different detection logic, how are you going to manage it? So ideally, you have any number of these. We have approximately at any given time somewhere between 120 and 150 different what we call plays. And so we need a way to manage these plays, and that's where our playbook comes in. And so this playbook is organic, something that we built. It's specific to our organization, and inevitably, every time that we give this talk, somebody raises their hand or approaches us afterwards and says, "Can I have your playbook?" The reason that we're doing this and the reason that we're writing the book is because that playbook, like I mentioned, is specific to our organization. So there's that Chinese proverb that says, give a man a fish, you feed him for a day. Teach a man to fish, you feed him for a lifetime. If I give you this playbook, out of 120 plays, I'm sure you could probably use a handful of them, maybe 5, 10, 20. But they're going to be very specific to our environment, and it's not going to give you the knowledge that you need when you stand up another service or another product to then figure out what it is that you need to monitor. So rather than give out this playbook, what we wanted to do is give you guys the methodology that you can use to apply it within your own organization. And again, that's the point of the talks that we've been giving and the book that we're writing. So what exactly is a playbook? We assigned it a definition. It's a prescriptive collection of repeatable queries or reports or plays against security event data sources that lead to incident detection and response. It's pretty basic, right? But it covers quite a bit of things there. The idea is that if we bring on new staff into our environment, we want those staff, that analyst, to be able to come up to speed immediately and understand what exactly is it that I have to do in the playbook to actually detect threats. And so we've structured these plays so that anyone can sit down and understand exactly what it is. Each one of the 120 or so plays that we have is set up in this way. And this is just an overview. I'll walk through this with you guys. Each play has an objective. The objective is simple. Well, it's not necessarily simple, but it's very straightforward in what it tries to do. That describes the intent of the play. That gives any background, maybe web links, maybe the reason that we're doing it, why we set it up, what was the impetus for it, why is it there? What are we trying to solve here? What problem are we trying to solve? The next thing is the analysis portion. And what the analysis means is that if this play or this report generates an event, what then do I do with the event? As an analyst, how do I actually look through that event and do something with it? Do I have to go into another data source that's not in our corpus because for whatever reason and correlate it over there? Do I have to escalate to somebody else to see if it's a true positive or a false positive, or to get more context? What is it that I need to do? And it's incredibly prescriptive. It's a step-by-step analysis. The next thing that we do is assign a fidelity to the report. Ideally, every report that we make is going to be high fidelity, meaning that if an event fires from this play, we know with 100% certainty that it is malicious behavior. Now, the reason that's important is because if you can know with 100% certainty that every event is malicious, then you can automate it, and you don't need an analyst to sit there and look at it. So you can take that event and you can feed it into your BGP black hole system, your DNS RPZ system, your process with IT to go and get the host, whatever it is, whatever you have to do. If you can automate it, that immediately removes any resources that you have to spend from your personnel to look at that. The vast majority of our plays are not high fidelity. It is really difficult to generate queries that 100% of the time detect malicious behavior. It's just simply really difficult. So the other category that we have are investigative reports. And like I said, this encompasses most of our plays. The idea here, though, is that an investigative report requires some set of human eyes to actually look at that result and do some analysis with that. But once they do that analysis, they have to determine, is that result a true positive, meaning it's something malicious that we can act on, or is it a false positive? We actually have a couple other categories as well. We have benign, meaning we expected to see it. It's something like a qual system, so it's malicious, but it's not something we'd act on. And then we also have indeterminable, meaning there's just not enough information to understand what's going on. Those are the four categories of that we assign to events. But for the plays, it's high fidelity or investigative. So if we determine that an event from a play is anything but a true positive, the next step that the analyst has to take is some amount of tuning. And the idea behind tuning is that the next time you run this report, if you determine that a result is a false positive, you don't ever want to see it again, right? That's just, you know that particular result is not worth looking into. You've confirmed that, so you need to remove it from the report somehow. How you do that is really dependent on the data sources that you're looking at that generated these alerts. It's dependent on perhaps who is looking at it. But ideally, you want to filter it out. Tuning is just filtering. And so by doing this iterative process, we run our reports typically twice a day. And what we expect to see is that over time, these reports start moving closer and closer and closer to high fidelity. They'll likely never ever reach there, but the more tuning that you do, the more that you know that you're weeding out any of the false positives. And that's the idea. We assign a severity. It's either standard or high. It's pretty binary. And the reason that we do this is so that we can understand if we have what amounts to a hot threat or a very topical threat that we're facing right now. Perhaps our management wants to know about it. They want to be kept in the loop. Heartbleed, shell shock, these are some things that would probably be considered high severity. And by tagging these reports with a severity level, we can then report on the events that fire from these reports and do some metrics on them. We also include information about containment. I mentioned this is in the analysis section. What is it that you do with the events after they fire? Do you take some action on them? Do you not do anything? Do you open a case to have a host reimaged? What is it that ultimately has to happen to actually stop the threat that you're seeing? And then we also include a set of references. These are things like help desk cases that might have generated this, that provide background information. Say you have an incident that you investigated, and out of that incident, during the postmortem, you understand, or the lessons learned, you go back and you understand, well, we probably could have detected this. Well, you can put a link to that case so that there's a history there to give more context into the play. We also include wiki documentation, really any documentation that is going to help an analyst look at this play. And then the last thing is that our report name is very structured. And the reason being here is that I'll show a screenshot in the next slide, but we use Bugzilla for our playbook, to store our playbook. There's no real reason that we use it besides that we had a Bugzilla instance for some other stuff. Our engineering team used that to keep track of our infrastructure and deployments and bugs. And we found that it works really well for reports. For a couple of reasons. If anyone's ever used Bugzilla, you know that there's fields that you can create, text boxes, drop-downs, radio buttons, that you can assign some of these types of things. And then there's a comment section. So I mentioned the tuning. We want to know how a play has progressed from the time that play was deployed. So we want to know how it started, what happened on maybe the first time it was run and the first tuning happened, all the way until the present day. We want to have that history. And the comment section in Bugzilla is absolutely fantastic for that. It's got a date, it's got a comment thread, it's a free-form text field that you can put, you can have a debate with it, and we have a QA team that looks at these reports and is keeping these plays moving. But with the report name, we have a very prescriptive report name, includes unique identifier. Every play gets an identifier. The unique ID range, it's actually a range per data source. So for instance, I think we have 6 characters in our ID ranges. Our IDS systems will be 00000 to 100000. Our web proxy might be 100001 to 20, et cetera, you understand. We identify whether the play is high fidelity or investigative right in the title. We also mention the event source. From where is it that we are getting this data? What is the data source? We talk about a report category. This is something like, is it malware? Is it a hot threat? What type of report is it that we're looking at? And then we have a brief description of the report. And so here's an actual example of an actual report that we have. You can see that this one's numbered 300,021. It's an investigative report. It looks at WSA, which is an Ironport product. It's a web proxy. That's what we use. Blue coat, whatever you want to use. This just happens to be our web proxy. This report looks for malware, and it's looking for posts, HTTP posts, to this gate.php script that we've found is associated with a whole bunch of malware that does information theft. So I think somebody was poking through at a known exploit kit, and they saw this commonality with gate.php and then a question mark and some parameters afterwards. And they worked backwards to determine that this particular script was associated with a whole bunch of malware. A lot of exploit kits actually use this. You can see in the second box that this is actually deployed as opposed to in progress or retired, right? Our plays, like I mentioned, it's organic. There's a life cycle of the play. It is a normal priority, meaning it's not high severity. And then in the last box, you can see there the objective. I'm not going to read it to you. It just describes, why and how we found that this gate.php was malicious. Gives a background to it. And we talk about the analysis. Analysis says it's pretty good fidelity. It's not 100% fidelity, so someone still has to look at it. We have an example of an alert that fired there. You can see the beginning of it. So we provide enough information to an analyst that if they were to sit in front of there, they've got everything that they need to know to understand what's going on. We also include the Splunk query, which I guess gives away what we use for our SIM. We store the vast majority of our data in Splunk, everything actually besides NetFlow and besides our DNS query data, everything goes into Splunk. We moved off of a SIM at this point maybe 5 years ago, and we like maintaining control of the data ourselves and how we access that data, which, like I said, is the whole point to this monitoring methodology. Rather than letting somebody else tell you what event that you should be looking at, we want to write the logic that generates those events, and that's what we have with Splunk. It gives us a really powerful query language to correlate across multiple data sources and to sort data and to manipulate it in however we want to do that. And then lastly, there's the report name. And so with this, with the database that Bugzilla uses, we're able to attach some sort of graphing solution to this so that we can run reports on this and do things like, when was this bug last updated? What is the state of the bug? Okay, so now we're going to take a look. We're going to go into the cloud here. Everybody has a different definition of cloud, including my mom, who uses the cloud to back up her photos. When I talk about cloud, what I really mean is a scalable solution that allows you to basically stand up and tear down the entire layer 1 to layer 7 stack. That's really what we mean here. Cisco decided to get into the business of the cloud, like Amazon, like Azure, like Rackspace. We just felt that we should be in that market as well. And so we're going to take that monitoring methodology and we're going to apply it to this cloud environment here. And the first thing that we're going to do is we're going to understand what is it that we're trying to protect. Within our cloud, there's this is semantics here. We're just going to get some definitions out of the way so it helps explain what we're doing. There's 3 environments. We're looking at a platform, which is the infrastructure. We're looking at Cisco tenants, meaning that it's our own tenants that are using this. And then we're selling the service, so there's non-Cisco tenants. And the reason that matters is because Cisco tenants have to abide by Cisco policy. Non-Cisco tenants don't. So the enforcement of those policies won't apply to non-Cisco tenants. Platform is built on OpenStack. This image is taken from OpenStack. I'm very, very briefly going to run through OpenStack here. Understanding what it is not really important for this exercise, but I did think it was fair to walk through it. There's a storage system. All these components are APIs that OpenStack provides. It provides a storage service. There's a compute service. There's an auth-N and an auth-Z service called Keystone. And then there's a web front end called Horizon. There's a couple other components as well, but these are the main ones. And if you start thinking about these components, you start thinking, okay, well, there's a web front end there that somebody might authenticate to. So there's going to see web requests into there. They're going to authenticate. We've got an authentication store. It's got an open LDAP backend. If you start thinking about what it is that you want to protect and what the threats are, you can start thinking, okay, well, SQL injection. Again, to go back to that, it's a really simple example. There's an exposed web front end that takes input. That's going to be susceptible to that. You're going to have authentication logs. You're going to have data on your storage that you need to look for possible data breaches or data exfiltration. So you start walking through this exercise based on the infrastructure that you're trying to protect, and it starts giving you an idea of what it is that you need to protect. So I just chose, we went through an exercise and we listed out a whole ton of different threats that we found against this. Some of them we determined ourselves, some of them we had a red team or a penetration testing team help us identify. But I just listed out a couple here. So there's some threats against the platform, there's some threats against the tenant. Some of them, it's not necessarily mutually exclusive. You'll see that we could have malware in either. We probably could have data exfiltration or command and control in either as well. But these are some of the different threats against those APIs that we have. So now that we've figured out, well, okay, I know that my platform might have configuration integrity issues. How is it that we're going to determine what it is that we detect? How are we going to detect the attacks against this platform? And so if we run through all of these, we start thinking, okay, well, I think that I can detect some of these. I think I can detect a DOS attack with NetFlow. Right? There's a couple ways you could do that. You could look for maybe 0 bytes in the response traffic, maybe a disproportionate. Maybe look for disproportionate traffic on certain UDP services that are susceptible to things like UDP amplification attacks. You can look for scanning, right? Horizontal scanning or vertical scanning, meaning is it going after the same port on multiple hosts or is it going after every port on one host? All these types of things you can detect with NetFlow. How about IDS? Signatures are built in to detect malware, command and control, scanning. Host intrusion detection system, we know on the platform that we want to make sure that the configuration does not change, so maybe we'll deploy a HIDS, which is something we're currently evaluating. We've looked at web app firewalls and layer 7 logs to detect some of the things, again, like SQL injection, cross-site scripting, abuses against our web-facing services. And then finally, the DNS for things like command and control against known bad DNS names or DNS servers that host DNS name servers. So what exactly, now that I've got these reports, what am I going to do with them? How am I going to respond? There's two things that we did here. We have an incident response handbook. We made an addendum to that. Hopefully everyone here has an incident response handbook. I'm not really sure how you can do this job and pass any audit without having the handbook. This is what we throw at the auditors, a redacted version of it so that it satisfies all their controls. But we added a portion here that says anytime you see an event fire, this is the process that you walk through. And it identifies the parties that you need to engage. We gave this to those parties. We went through this in that tabletop exercise that I mentioned to make sure that this process works and that we're engaging with the right folks. And the other thing that we did is we stood up an acceptable use policy, and then we published this with the service. So anytime someone signs up for the service, this is the fine print that they check and they say, I agree. But what it does is it gives us the ability to act on things that we're seeing. So this says, there's a lot of fine print in here. I'm not going to read it to you by any means. It's actually public if you want to see it. But it says things like, Cisco has the right but does not assume the obligation to monitor and investigate violations of this policy. It also says that we can take actions necessary to mitigate threats that we see, meaning that if you're misbehaving on our service and you're causing impacts to our service or to other tenants, we're going to shut you down. It doesn't say how we're going to do that, but it's enough to justify any actions that we need to take to keep the integrity, the availability, or the confidentiality, the triangle of our service there. And so it's a combination of the incident response process, the handbook, as well as the AUP that allows us to actually do something when we see these events. Okay, so I should say that this service, the Cisco Cloud service that I'm talking about here is, we're really, it's still not in production. I think the go live is end of November. So it's still a process that we're going through to tune things. We're still trying to get logs. The business is still trying to figure out what exactly they're going to put into the service. But that being said, as of the plane ride over on Sunday, we had 39 incidents that came out of this environment based on our monitoring methodology as well as incidents that were investigated to us. Of those 39, 75% of those, 29, were things that we detected with that monitoring methodology that I just showed you. And we know this because we have all that information that we can query because the data, because the reports are structured. We have 8 unique plays. I think right now we've got 4 or 5. Some have been retired based on decisions the business made to pull tools out or whatnot. But we have, at any time, we had 8 plays that were associated with this. And so far, we've had 100% true positive detection rate with our plays. That's not going to stay. The fact is, there's no way that we're going to continue that. But since we have it right now, I thought I'd list it up there. I thought it was pretty cool. And that's really it. Any questions?
How do you select the right alarms to investigate? You mentioned that you have 1 million dot point alarms per day.
So I think the question is, how do we decide of those 1.5 million which ones we're going to actually investigate, right? So those are the events that are generated, very much like if we were to collect a log. So think of that as just a log. Not every event in a log is something that we're going to want to investigate. Maybe it doesn't apply to our situation. Maybe we just don't deem it that critical. So we go through those and we sort them. So when we first stand an IDS system up, by this point it's pretty well tuned. But when we first set it up, we go through the most frequent events. You start at the top, and then you weed out ones that you know don't apply. Maybe you know that Shell Shock. Sorry, maybe not Shell Shock. That's a bad example. But Heartbleed released an IDS SIG. okay, we want to pay attention. We want to make sure that that signature is called out. So we'll set up a report that just looks for those signatures. It's going to be a portion of the 1.5 million, but we know it's an important one. So we'll go through and we'll start picking ones out that we know are malicious. And the idea is that if you've done that enough times, you're eventually going to get through all 1.5 million. Are we ever going to get through all 1.5 million? Probably not. But you have to start with the ones that are the highest criticality to you and your environment. Does that answer your question? Okay.
Thank you very much.
I have just one question. You split the report between objective and analysis part. And my question is really simple. This objective is always predefined, and analysis is a part that is generated by a human?
Well, they're both generated by humans. And in theory, we probably could put them in the same text field. But to separate the background to the report, the reason that we did that is that the objective portion is actually something that we probably could provide to folks. So if you wanted to know, well, what does this report do? That's going to be much different than the analysis portion, which is going to be very specific to our environment. So we've just separated those out so that if we ever have to generate an explanation of all the different types of detection logic that we have, we could just look at the objectives.
Okay, thank you.
Mamy czas na jeszcze ostatnie pytanie.
We have time for the last question.
Jeśli nie ma, to thank you very much.